Okay, so trig functions. Let theta be an angle in standard form and P, the point P with coordinates x, y, be a point on the terminal side of theta. The distance from P to the origin, r, can be found using the formula x squared plus y squared equals r squared. That's the Pythagorean theorem. So here's what they're saying. Here's our angle in standard position. Here's r. Here's our point. The distance from here to here is r squared plus y squared. Okay? So if you remember the distance formula, it's all the same thing. Okay? So if we wanted to find this point, this would be our angle theta. The way they did this, it kind of makes me mad because really theta is this guy right here. Not this guy. This guy is theta. For all of these, this is theta. Okay. So to find the sine, cosine, and tangent values and other trig values of this guy, so this is our y distance because it's y. This is our x distance because it's the x-axis. Then we call this r. And the reason we call that r is because this forms the radius of a circle when you drag it all the way around. And that's how we use the unit circle. That's concept 4, so we don't need to worry about that yet, but that's why it's r. Okay, so the sine of this theta is opposite over hypotenuse. So opposite over hypotenuse, so y over r. Okay. Cosine of this theta is adjacent over hypotenuse, so x over r. And then tangent is opposite over adjacent, y over x. Okay. So cosecant, you just flip those two, r over y. Secant, r over x. And cotangent is x over y. Okay. Those are the 6 trig functions using a triangle in the coordinate plane. Okay, we're going to do an example with this. So what you're going to do is you're going to use this to draw a picture. Okay, so I'm going to give you a point and you're going to have to draw a triangle. So the point P, 5, -2, so 5, -2, is a point on the terminal side of theta in standard form. So here's our angle here, which means theta is actually this guy, but we're going to do theta this side. Okay, so theta is our angle here. Find the exact values of the trigonometric functions of theta. So 5, -2, so that means if we went over 5 and down 2, that means this side here has a length of 5, and this side has a length of -2. Okay, we say it's negative because it's actually on the coordinate plane. So we need to figure out what this side is, right? So let's redraw this triangle over here so we can do it a little bit easily. So here's theta, here's our right angle. We know this is 5 and this is -2. We need to find this side. We're going to use the Pythagorean theorem to do that. That's why we mentioned that up here. Okay, so 5 squared plus -2 squared equals r squared. 5 squared is 25 plus 4 is r squared. So 29 equals r squared. So r equals the square root of 29. We can just leave it like that, square root of 29. So now we know all the sides. Now we can find all the trig functions. So the sine of theta is opposite over hypotenuse. This would be -2 over radical 29. Cosine would be adjacent over hypotenuse. And then tangent would be opposite over adjacent. All right, oops, sorry, you can't see that. Remember, to find the other 3, all you have to do is flip them over. Radical 29 over -2. Radical 29 over 5. And 5 over -2. All right, so that's it for concept number 3. I know there's a lot, but you will be getting a note card today at the end of class if you have all of this stuff done to help you prepare for your test on Wednesday, Thursday. All right, so that's it.